So I've got this website. It's called buymoreflats.com. It's where you can go to buy more flats. It looks like that. We spent millions on our web design. Yeah, I know what you're thinking. That's not a flat, that's a house. We also do houses. It's got a lot of code. And a while ago, I started to think that it wasn't quite as good as I thought when I was first developing it. So I'm the lead developer and the CTO and the product manager and the product owner and the business analyst and probably some other things. I can't remember. I've got 14 different business cards. So the code's not quite as good as I thought it was when we first getting started. So I got to work, and this is what I found. First, I want to talk about readability. Audience participation time. Which one's more readable? This. Maybe neither of them are readable if you're at the back, so just come and edge forward. So is this more readable, or is that more readable? Someone who can actually read it, tell me. Bottom. Anyone disagree with the bottom one? Bottom one. Top, top, top. Is it split along like the room? Is that side of the room like the top half? Is it just that's the side you can read better? Okay. So it's probably helpful if we define readable. So here's a definition that I pulled from the dictionary. There are actually two definitions. The first one says able to be read or deciphered, legible. The second one says easy or enjoyable to read. I kind of locked the second one out because code that is enjoyable, that's kind of cool. I'd like to read more of that, but I'm really, really interested in the first one. And if I remove all of the boring words from there, I think it gets a bit more interesting. So the synonyms is really what I want to concentrate on. Legible, decipherable, clear, and intelligible. I can't pronounce that word. Understandable, comprehensible, and the antonyms, illegible, indecipherable. So now I'm starting to get a bit more of a feeling about what readable means. So going back to the code samples we had earlier. Oh, those colours really aren't coming out, are they? So the name, the first one was called Search for Properties. Property website, you remember. The second one didn't have a name, it was actually called ABC. Buying or renting. The first one is a Boolean, renting. The second one is a purchasing type. I'm going to give that one to the second one because, sure, if it's true, then I'm renting. If it's false, what am I doing? Whereas purchasing type is an enumeration that has buying and renting as the two values. Monthly budget. So I can either have an integer monthly budget or I can have something of the budget type. Probably goes either way. The center coordinates. I have latitude and longitude, or I just have a coordinate type. Maximum distance. So I have a double, which is the distance from center. Thank you. Is that now more readable? Yes. Sweet. Thank you very much. On the second one, I have a radius. I think the radius wins here because I have absolutely no idea what distance from center really means. Like, it can say 2. Go on. Radius. So 2 distance from centers, how many miles is that? Is that 2 miles, or is it actually 2 kilometers and it's only a mile and a bit? I don't know. And the return type, it's either a stream of integers or a stream of property IDs. It probably becomes more interesting when I actually call the function. So when I call the first one, it looks something like this. I pass it true for renting, 500, that's my monthly budget, the coordinates, which I'm searching around, and 2. 2 distances. Fathoms, furlongs, I don't know. By contrast, when I call the second one, I tell it it's a property type of rental, a monthly budget of 500 Great British pounds, coordinate of whatever that is, I think that's Greenwich, and a radius of 2 miles. So that tells me a lot more about what I'm doing. Notice that we combine the 2 doubles into a coordinate. I want to take that a little bit further. So a coordinate, point on a map. Radius, area around that map. So we can go one further. Just like we took the 2 doubles and made it a coordinate type. I can take the coordinate and the radius and combine it into an area. So I've created a type called circular area, which wraps the coordinate and a radius and just implements an interface called area. So now I've got 3 things that I take in that method instead of 5. And I call that a win already because less is better than more, at least when it comes to code. I want to go one further. So I want to combine those 3 things into one thing. So if I have a purchasing type and a budget and an area that I'm interested in, I'm searching for a property, that function currently runs that query and returns back to me a stream of property IDs. Stream kind of like an iterator, for those of you who may not be aware, by the way. It's just a thing I can traverse through and get all of the things out. So I can take those 3 things and make a search query. That's what it is. So when I refactored that to that, I ended up with this new interface I didn't have before called search query, which represented a query that I was about to execute, not one that's already been run and I've got a bunch of results back, but a query I was about to execute. So I ended up separating the construction of the query from the execution of the query. And then the query looks like that. It's got a fetch method. It also has a fetch1 method for convenience. So I hope that kind of explains why changing the inputs to be more typed makes sense. But the output is kind of weird, right? So I had a stream of integers and I changed it to a stream of property IDs. But a property ID in my database is just an integer, so why bother? Well, so here's my property ID class. It wraps an integer. I can construct a query from it, which creates a search query of property. So given a property ID, I can go get all of the information about that property. Very useful for when I hit a URL with the ID in, and I want to actually see all the information I can about that property. It's got a render method, which I use purely for constructing URLs and things like that, so it can make those URLs. And of course, it's got equality, hashing, and toString, which are your standard things that you use everywhere in Java. I'm sure whatever your language of choice, it has similar things. So property ID has 6 kind of behaviors. It can construct a query, it can render itself, it can convert from an integer to a property ID, it can convert from a property ID to a string, it can check equality against another property ID, or really any other object, but we're probably only interested in checking equality against other objects of the same type, and it can hash itself, so it can be used in a hash-based collection, like a hash map or a hash set. Contrast this with what you can do with an integer. These are the behaviors on integer, so let me just run through them. There's addition, multiplication, subtraction, division, modulus, negation, bit manipulation operations, further bit manipulation, functionality, equality, hashing, comparison with other integers, treatment as an unsigned integer, treatment as a sign, conversion to and from other number types such as double, conversion to and from strings in decimal, hexadecimal, octal, and binary, and there's actually a lot more which I haven't listed here. So comparing property ID to an integer, there's a little bit of overlap. You know, the standard stuff, equality, strings, hashing. And there's a couple of pieces of functionality on property IDs that you can't do with integers, at least not natively. You have to go write additional behaviors. But there's a bunch of stuff I can do on an integer that I cannot do on a property ID. I can't add 2 property IDs together. I have no idea what that would mean. I take the ID of one object in my database and add it to another object in my database. That's probably meaningless. You don't get 2 houses out of that. By wrapping the integer in a type, I haven't got an added more behavior. I've actually taken loads away. And that's what I really consider readability to be. It's about decipherability and understandability. When I see a property ID, there are really only 2 things that I really care about that it can do. It can query the database or it can render itself. By contrast, if I see an integer, I have no idea. I have to go read all the code to understand what I can do with that thing. It could be doing anything. It could be multiplying it with another ID of a different type. It could be multiplying it by 7, because why not? And that, to me, is the definition of readable. Doing less. So flexibility. Here is the implementation of that search for properties method. So what it does is it constructs an SQL query, parameterizes it, passes in the relevant values. Because the area is probably a circular area, we actually convert it to a rectangle, pass that to the query, and then do some post-processing filters to get that stuff, but that's probably not important. The other thing it does is when it finally gets a value out, it takes the integer ID and converts it to a property ID. because that way I never actually expose the ID itself. This is using filter and map. They're not actually methods on collections, they're a method on the query, but I use the same interface because it makes sense to me. I'm just telling the query when it runs to do some transformation afterwards. Does that make sense? Any questions? I'm going to take that as a no. So you remember our property ID class? It's got an integer value and some other stuff. So it's got an integer value because it's really wrapping an SQL row, or SQL column field, rather. So there's an ID for our properties, and this represents that ID. And that's because we were using Postgres, so it made sense. But the website was going slow, so we solved the problem by switching to Cassandra, because that solves everything, right, Chris? By the way, if you have any Cassandra questions, ask that guy. So instead of having an integer now, because Cassandra is a distributed database, it doesn't use integers for identification, because counting in a distributed fashion is basically an unsolvable problem. So it uses universal unique identifiers, UUIDs. We kept the integer for the human representation because it's much nicer to see numbers in URL than big, long strings of numbers and letters. So we needed to change our search query, obviously, because you can't just run SQL against Cassandra and expect it to work. Actually, you probably could in that circumstance, but close enough. So we switched it out for this Java-based DSL that you can ask Chris lots of questions about if you're curious. The filter stays the same, and we construct the property ID slightly differently now. So we get the UUID and the integer, and we just pass it through. Nothing else changed. Nowhere in my code base did I have to go start changing integers to UUIDs everywhere, because it was already wrapped. I'd gone from having a primitive, an integer, to a domain type, property ID. That's something that, the property ID is not just a thing that exists in my database for convenience. That's a core part of what my business is, properties and identifying them. So by lifting that number out of the technical world and into my business world, I'd actually raised a layer of abstraction. And by having my code reason about the abstraction rather than the concrete value, using property ID everywhere instead of integer, I was able to just change one place and have all the rest of the code just work as expected, because it still did all the relevant things. It did queries and it did rendering. Made it more flexible. Correctness. So in his book, Understanding the Four Rules of Simple Design, a chap called Horry Haynes talks about a very important concept that we'd never really named before. It was kind of known, and people have observed this for a long time, but I'd never heard a good name until I'd heard the name behaviour attractor. So let me give you an example. So in my original search for properties function, distances shouldn't be 0 or negative. That is a bad thing. If you have a negative distance from a coordinate, the world implodes or something. So we've got to check for that. So we do, if this thing is less than or equal to 0, we throw a legal argument exception. And then we do that everywhere, because it turns out we have distances in a lot of places, because I run a property website. You have to deal with distances a lot. It turns out properties exist in the real world. So it's not very nice to see that everywhere, and ends up with a lot of duplication. So what we did was we made use of a couple libraries and made it slightly prettier. So this is the same code, it's just abstracted away a little bit. So check that distance from center is greater than 0. And that will throw the same exception if it fails. But I still have to duplicate that one statement everywhere I have a distance, which sucks, right? I have code everywhere, and if I miss it in one place, potential bug, potential security vulnerability, I don't know what will happen, because I never tested for negative distances, because that's not a valid case in my business. So I should have that check everywhere. Every single place you ever see a distance, you should see that same check, which is error-prone. Why trust a human to do something computers are really good at, which is just to do the same thing over and 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 over again? When I introduced my radius type to represent that the distance, it gave me a really useful place to put that check. I could just put it in the name constructor. I call these things name constructors, when you have a method that just wraps the constructor. So in the name constructor, I just moved that check there. Problem solved. I don't have to duplicate it anywhere again because my distances are not integers, or doubles, I think it was. They're radii. That's the power of a behaviour attractor. By constructing a type, behaviour that was once scattered all over my code base has now been attracted into a single place. It has a place now. It's not just a thing without a name. It's now a core part of this entity. I haven't been totally honest with you. There's more code to this function than you might expect. It's not really code. It's actually a comment. Comments are bad, I know. So this is JavaDoc. Those of you from C# world will recognize it as a variant of XMLDoc. It has some text about the thing. It's got all the documentation of all the parameters. It documents what it returns, a stream of property IDs. Easier if you just call it stream of property ID, right, in the type system. And it throws a database query exception if there is a connection error, which is pretty reasonable. You don't want to just return nothing. You want to explain to whatever called you that there was a problem. So when I refactored to use types, I could get rid of most of that documentation. I mean, parameters and return types, I no longer need the documentation for because now it's documented in the type itself. You can read it. I didn't need to say it returns a stream of property IDs because that's right there. But I do still need to say that it throws a database query exception. And when I make that return a search query, I just move that documentation elsewhere. So in Java specifically, we have something called checked exceptions, which everyone hates. Everyone hates these things, apart from me, because I can take that documentation, and turn it into code. And now I don't have the comments anymore. I have code that verifies what I'm doing is correct. So instead of documenting that it throws a database query exception, I force the caller of this function to handle this database query exception. And you end up with code that looks like this. Who can read that? Nobody. Excellent. I can barely read it. I'm standing right next to it. So let me remove all the guff, and now hopefully you can read it. So I've got a property details function which calls property response. Property response calls formatted property. Formatted property calls retrieve property, and that does a database query. So that throws an exception which bubbles up in the throws block because I only ever want to catch it at the top level. That's awful. I don't have to see throws database query exception all over my code. So Steve Freeman and Nat Price wrote a book called Growing Object-Oriented Software Guided by Tests, and they're fond of saying something that Sandro hates, which is listen to your tests. I actually really like that statement, as long as you don't just say listen to your tests and then wander off like you've solved their problem. You actually have to say, here's what your tests are telling you. Here's an example. So to paraphrase them, your types are trying to tell you something. You should listen to them. In this code, the throws clause is part of your type signature. Property details is a function that accepts an integer, returns a response, or actually not that one. Property response is a thing that accepts a property ID, returns a response, or throws a database query exception. That is now part of my type system. My compiler is verifying that the type is the return type, which is response or database query exception, is handled appropriately by the caller. If I failed to catch in the function above, it would fail to compile. And my types are trying to tell me something. If I have that duplicated everywhere, it means the structure of my code is wrong. So compare it to this. So this time, the top function calls retrieve property, then passes the result to formatted property, then passes the result of that to property response. And now only the bottom function throws database query exception. So just by restructuring the code and listening to my types, I was able to make the code cleaner in ways that I may not have noticed if I hadn't had that type be explicit. If I'd been using a runtime exception, which was what was happening before, I would never have noticed that the structure of that code was all wrong. And I should be trying to call the database fairly close to the top level instead of burying database calls several method calls deep in my program. So now I have code that looks like this, which is just as ugly because it's really big. And one thing you may just about be able to spot is there's some duplication. So in these two middle functions, I first check if the input value is null. What do we do with all that duplication? I bet they're not the only places in this code base that say, if thing is null, return null. So here's your basic template. If thing is null, return null, otherwise do a thing. Right? That's how most of my functions in my code base started. So I started refactoring. So first of all, put it in an else block, because then I can reason about it a little bit better. The next thing I did was, you see that comment where it says process thing and return? That's kind of the abstraction. So what I did was I lifted that abstraction out into another piece of behavior. I created a function object that represented that abstract piece of code that I didn't know anything about. So for those of you who are not familiar with this syntax, this is, in Java terms, it's exactly the same as constructing an implementation of an interface, where the input is value and the output is whatever that comment is, and the method is called apply. In C# terms, it's a lambda, you know what it is. Once I had that thing, I could pull it out as a parameter, because now it's not just a comment, it's an object. This is the optional class in Java 8. There are many just like it. So in Scala, it's called option. In some languages, it's called maybe. I believe there's third-party libraries all over the place where you can get it for C#. In F#, it's called option. So it has a value, and the value can either be null, nothing, or something. And it has a function called map, which accepts, or a method called map, which accepts a function, which we'll call mapper, which is a bit like our processor. And if the value is null, it returns a new optional, which is empty. It's got a null value. Otherwise, it applies the mapper to the value and then returns a new optional of that type. So we start with, instead of starting with a type of t, instead of starting with a type of input and output, we start with a type of t, which you can consider to be the input, and end up with a type of u, which you consider the output. But it's wrapped in this optional thing. So optional of t transforms to optional of u. And we can call it like this, so thing.mapProcessor. So our process method is now a very, very thin wrapper around the map function in optional. And because an optional is never null, or at least should never be null, you can make null ones, but please don't, I can just treat it as a thing without having to do that null check every time. And I can just use that map function and just pass behaviors through that. So instead of doing null checks everywhere, if you look here, instead of taking an output which could be null, I take a maybe output, which is optional. And then I can map it over something. And if it's null, if it's empty, I can give it a value using the or else function. Just here's a value, be this instead. And now my transformations don't have any null checks. And I actually use map at the top up there as well, so I can remove the null check down here. What I like about this is because now every single function is just a flow of execution. There's no ifs, there's no buts, which means I can just inline everything. And that's exactly the same code. So I do a query, and then I do a format, and then I can transform it into a response, which was exactly the same flow we saw earlier. Those were the methods that the top function was calling, and we handled the exception in exactly the same way. But by abstracting away the null check into its own type, optional, we've removed the need for checking that everywhere. And when I eventually forget to write a null check, and who hasn't forgotten to write a null check, my program won't break because it's in my type system. So I can be pretty sure that my program is correct without having to worry about, is this thing null at every turn? Efficiency. So on buymoreflats.com, we let you shortlist properties. I should probably explain what a shortlist is. A shortlist is a thing where I'm looking at a flat or a house, and I like the look of it, but I don't want to make any inquiries straight away, so I just add it to my shortlist. And then I look at 5 more and I add them to my shortlist too. And then I can go back to that list of 6 things later. So we do a database query. This is back when we were still using Postgres. And then we do some transformation. We end up with a set of shortlisted properties. We then sort that according to the date time added. So if you added it, it shows the ones you added first at the top. We then group those by the city they're in, so we can give you headings. We then get the list of cities, so we can actually construct those headings, set of cities rather. But if any of those are up for auction very soon, we need to show those at the top, because otherwise you might miss them, and that's bad. So if you have 20 things in your shortlist, you really want to see that one that's up for auction soon. And we're going to promote a random auction in your shortlist just to see if we can make some extra cash on the side. We managed to get a lot of sales that way. So the highlighted list is actually first the random promoted auction, and then the stuff that's up for auction soon. And we've got loads more features coming every week. So I do all those things. And then I thought, okay, let's move them all to a type that represents that shortlist. And I ended up with these 7 things. But I actually only need 3 of them. The other 4 were used to construct those 3. Well, in doing all of that, we actually processed the original list 5 times. We run through it 5 times, which doesn't sound like a very expensive operation, but if you've got 1 million hits a day, that's a serious waste of time. And of course, everyone's clicking things at random. You have to generate that every time, because on a web server, you don't often cache this stuff. You just generate it over and over and over again. So each time we construct one of these things, we run through the whole list again. By moving it to its own type, well, we don't need to optimize our algorithms, right? I'm using a database. They've done a lot of optimization in the database. I should just use it. We just need to write code that does less and allows the infrastructure that we rely on to do a bit more. So if I write code that just generates those 3 things, I'm now running through the database 3 times instead of 5, or at least the list 3 times instead of 5. I save some processing time, which matters when you've got 1 million hits a day. And I did less work. I have less code now. So by writing less code and relying on my type systems to do more, just by constructing a new type that attracted those behaviors, I was able to, excuse me, I was able to cut down on the amount of work each and every query was doing, each and every hit to my website was doing. Made it more efficient. I went through this way faster than I expected. So we tackled 4 discrete problems. There was readability, flexibility, correctness, and efficiency. I wanted to talk about security as well, but I didn't think I'd fit it in. So come find me if you want to talk about security afterwards and how your type system can help. The solution was always the same. Make a new type. So sometimes these were domain-specific types, like drawing a circular area to do a property search. Sometimes they were fairly technical and just a thing where we had a lot of duplication and we wanted to move that duplication somewhere where it belonged. So quoting J.B. Rainsberger, who was actually paraphrasing Kent Beck, I define simple design this way. The design is simple to the extent that it passes its tests. I'm sure there's lots of people here who will happily talk to you about passing tests. Minimizes duplication, maximizes clarity, and it has fewer elements. This was all refactoring. So I wrote tests first. They weren't all there to begin with, but I wrapped things in tests as I went, and everything still carried on. And my performance tests were very happy. We actually removed a lot of code by providing a space for code to move to. Code that was duplicated because there was no real place to put it, now had a place. We maximized clarity. We named things that didn't have names before, things like coordinates and areas and radiuses. Radii? I don't know. Radiuses? Radii? Whatever. I named the search query. I'd never had a search query before in the code. It was just run this database thing. We actually have fewer elements. Now, it may feel like we wrote a lot more stuff, like there are a lot more types in my code now, but every single one of them does less. An integer has hundreds and hundreds of potential pieces of behavior. Property ID has 6. A search query has 2 pieces of behavior. Can you imagine if I'd just been passing around SQL strings everywhere? How many behaviors does a string have? Well, I can run it as an SQL query, sure, but I can also concatenate it to another string, render it as HTML. I can reverse it. Has anyone actually ever reversed a string in production code? Is that actually useful? Or is it just a thing people do in coding competitions? Interview questions. I'm pretty sure there's no good reason to ever reverse a string. Strings are crazy. You can do anything with them. So by introducing the search query, I actually reduce the number of behaviors in my code base by orders of magnitude. I've got fewer things going on in there now, not more. I may have more types, but way fewer methods. It's not often that you get to minimize duplication and maximize clarity at the same time. Often we refactor to minimize duplication and we end up moving things around, and now it's really hard to read because we moved all of these things away. But when you're using your type system effectively, you can you find places to put things that are almost natural, they fit, and actually improve the clarity. Improve the clarity of your code without sacrificing readability or flexibility. In fact, improving it. So jackpot. Go wrap some stuff in types. And that's me. I work for Coherence. We have fun with code like this all the time. This talk is written as an essay on talks.samirtalwar.com, so if you want to read it at a slower pace, it's there. Heckling starts now. Any heckling?